So we're going to start with the derivative of e to the x. Okay? To find the derivative of any function, you always start with the definition of the derivative, which is what we started calculus with, okay, even from last year. So it's f of x plus h minus f of x over h. And if f of x is e to the x, then f of x plus h is e to the x plus h minus e to the x f of x over h, the limit as h approaches 0. Now, here, when you have e to the x plus h, this is also an important skill. You can write that as e to the x times e to the h. We did a little bit of this last year. You always know if you have this, you know how to go, in that direction. That's e to the x plus h, and now this is just in the reverse direction. So that's how we're going to write that, e to the x times e to the h minus e to the x. Now, you see how we have one term minus another term? And you see how they both have e to the x's? Let's factor out an e to the x. If you factor out an e to the x, then you get e to the x, e to the h minus 1 over h. And another way of writing that is you can put e to the x separately here. So you have e to the h minus 1 over h. Now, since it's h approaches 0, that limit only applies to terms with an h in them. So if e to the x does not have an h in it, we can pull it out. And it's just e to the x times the limit of whatever is left. Okay? Now here, as h approaches 0, this approaches 1, right? 1 minus 1 is 0 over this. That is 1. I know it's, trouble believing, but graph it, and it does end up being 1, only because like e to the h approaches functions values faster than h does, so that reduces to 1. So that means that reduces to e to the x times 1. That also means that the derivative of e to the x is just e to the x.
Why is it 1?
Okay? Graph it and you'll see, but it's because of, I don't have that much time to go over it right now. Okay?
E to the x graph goes like this,
right? Right, well...
How would be?
So obviously, this you have to memorize. All right? Now, if it's a function, where it's e to the u, not e to the x, then we do the chain rule. So the derivative of e to the u is e to the u times the derivative of the inside du dx.
Well, that's not that bad.
Okay, not at all. So let's do a couple of examples. Here I have y equals e to the 3x, and I want to take a derivative, and look, it's, I have a u there, right? So dy dx is e to the 3x times the derivative of that inside function, 3, so that's 3e to the 3x. Okay. Here, next one, dy dx is e to the, whatever it is, x plus x squared, times the derivative of the inside function, 1 plus 2x. And it's convention that we always write the algebraic function first, followed by the exponential, so it looks like this. Okay? How are we doing? Now, that was e to the x, okay? E, remember, there's nothing special about e, it's just, one of those irrational numbers, right? So e is just a constant, it's 2.7. E could easily have been like 3. So I could have e to the x, or I could have 3 to the x. There is literally no difference, right? So what if you wanted to find the derivative of a to the x? Like, for example, y equals 3 to the x. That's no different than e to the x. Well, the derivative, a to the x is actually e to the x ln of a, okay? But what you have to know is, I'm just going to skip here. The derivative of a to the x is a to the x ln of a, all right? So just tack on ln of a. So, for example, d dx of ln of 3, d dx of 3 to the x is ln of 3. Sorry, I just need to pause for a minute. The derivative of 3 to the x is 3 to the x ln of 3. Okay? The 3 and the e are sounding the same in my mind. Now, you're like, wait, but if e to the x and 3 to the x have no difference, then why is this different? But is it though? Is it different? Let's do that. Yep. Let's do that for e. The derivative would be e to the x ln of e, but what is ln of e? Just 1, so that's e to the x. So you see how it's consistent. Yep. Yep. That's that. You see that? It's consistent.
Oh, so that's why it's e to the x.
Right. So bottom line, you have to memorize that. Okay? All right. At what point on the graph of the function y equals this does the tangent line have slope 21? Okay. Well, first I need to find the slope, right? To find the slope, it's y prime equal to derivative of 2 to the t is 2 to the t ln of 2. Derivative of minus 3 is just 0. So that's the slope. I want the slope to be 21. Okay? So now, how am I going to solve this? Well, if I want to solve for t, let's divide by ln of 2. Yeah, 21 over ln of 2 is 2 to the t. Now what? Take ln of both sides. So I have ln of 21 over ln of 2 equal to, t comes down, ln of 2. So the calculus here stopped at the second step. And now it's like algebra 2. And now I still need to solve for ln of 2. Divide by ln of 2, divide by ln of 2. So t is ln of 21 over ln of 2 over ln of 2. Okay, and that's it. Nothing can cancel. And there is no, all this time we've been working with ln's, there was never a theorem that said there shall only be a maximum of like this many ln's in an expression. No, right? So this is just fine, right?
I think I got lost on step. So I have t equals ln 21 over ln 2.
And you take ln of both sides.
I think you stopped with the purple and then with the red.
Stop on the third line, yeah.
Yeah, so then with the blue, you have to solve for t. So divide by ln of 2, divide by ln of 2.
I thought when you take the t down, it's just t equals to ln.
No.
There's still the ln of 2.
Yeah, yeah.
So t ln 2.
Right, exactly.
Lots of it's still pre-calculated. This is mainly pre-calculated.
Right. Okay, so we did derivatives of e to the x and a to the x. Next, derivative of ln of x. Okay, so if you have y equals ln of x, in order to even do anything to it, we first, say e to the y equals e to the ln of x. That becomes e to the y equals x, and then I'm not going to go through all of it. Bottom line, the derivative of ln of x is 1 over x. Okay? Memorize. So if you have ln of u, it's 1 over u du dx. Okay?
You have to memorize both of them or just top of them?
The top one, I mean, but it's chain rule. The other one is chain rule, so you should always, know how to do the chain rule. All right. So here we go. Let's take a derivative of this. So let me write it nicer. ln of 10 over x. Okay? All right. So dy dx. The derivative of ln of something is 1 over the something. 1 over a fraction is another word for the what of the fraction? It starts with an R. Reciprocal. So it's x over 10 times now the derivative of the inside. And what is the inside? It's 10x to the minus 1. So the derivative of that is negative 10x to the negative 2. So here I get x over 10 times negative 10 over x squared, negative 1 over x. Right? So the derivative of like ln of table is 1 over table times the derivative of table. Like that's how it is. Okay? All right. So here, chain rule. dy dx. Okay, what's the outermost function here? The 2. So 2 comes down, ln sine x. Next, what's next? ln. The derivative of ln is 1 over the something, so 1 over sine x times the sine x is cosine x. Times 1, because there's an x there. Good. All right. Cotangent. Yeah, so this and this together are cotangent, right? So dy dx is 2 cotangent x ln of sine x. And so when it's like just cotangent of x, I like to move it to the front because here I have ln of sine x times the sine x, and if, it's easy to get crossed between the two of them, and, that actually was happening on the quiz, so you'll see in a little bit. Okay, so more power rule stuff, okay? So we know how to work with the power rule, right? Like if you have x cubed, move the exponent down, subtract 1. So, okay, if it's x cubed, fine. If it's x to the negative 2, fine. But what if it's some random number, like root 2, right? An arbitrary number. In math, arbitrary is the word we use instead of random, right? Instead of saying a random power, what if it's an arbitrary power? So if you have this, dy dx, well, what is this? This is still x to the power of some constant. So what if it's root 2 versus 2? The root 2 still comes down, and you have x to the power of the exponent minus 1. And as much as you want, there is no simplifying that. That's it.
That looks so up.
No decimals.
Yeah, it's not like
That's it. It's not 0.4. Okay? Okay.
Terrible.
Here, I have y prime equal to pi comes down, right? So what do I have left?
Pi sine x to the power of
Right. Pi, sine x to the power of pi minus 1. That's cleaner to write than to put it inside the sign, yeah.
Is the dx in both cases just 1? Is that right?
In that one. But here, times, now the inside function is sine, so it's cosine of x.
So the pi, sine pi of x is the same as sine x pi.
Yeah.
Okay.
Wait, Miss Malikan, how come you got rad 2x? I'm still a bit confused from that one.
Probably got the,
Because you know that.
Wait, wouldn't the sine x positive minus 1 be inside of them? And
So you can write it like this, but it's kind of awkward.
Okay.
Yeah.
that's odd.
It's just, I don't know. It's
Well, you might see
Is
the awkward.
it framed upon? Frowned?
frowned upon. So it's easy to get lost with them. Okay. Now, here we go. We've worked with y equals x cubed. Simple. Okay? We just learned how to work with 3 to the x. That's a to the x, right? We just learned that. You know what we haven't learned how to work with? So here, you have a variable in the base. Here you have a variable in the exponent. What we haven't done is a variable in the base and the exponent. What we haven't done is something like that. And that is what we're going to do right now. Okay? So this is the biggie of this lesson. This is the one that takes the focus, okay? That needs the focus. So that process by which we can take a derivative of something like this is called logarithmic differentiation.
That name just makes me.
Yup. We use it when you have a function where there is a variable in the base and the exponent. Okay? All right. 5-step process. First, take ln or log of both sides. We know how to do that. That's algebra. Okay? Use the power rule to move the exponent to the front. Also algebra. Here is the calculus part. Use implicit differentiation for both sides. Okay? That's the calculus part. Then we go back to algebra. Solve for dy dx. And then more algebra. Replace y with what y was originally. Okay? So, algebra, calculus, algebra. So let's do this. We need to find the derivative of this, x to the x. So first, we are going to take the ln of both sides. Yeah. Well, later on you end up getting with x in the denominator, or in an ln or something, and then that, yeah. Okay. So here I have ln of y equals ln of x to the x. Okay, I took ln of both sides. I haven't even done any math yet. This x comes down. That's a property in algebra. So ln of y is x ln of x. That's step 2. Now comes the calculus part. I need to do a derivative. Okay, so I need to do d dx.
Why do you need to do it?
Well, because we're finding dy dx, so at some point I have to take a derivative.
Oh, right.
d dx ln of y is equal to d dx of x ln of x.
Is that it?
That's a what rule? Product rule. That's a product rule, but you know, we'll get there later. Let's do this first. Implicit differentiation. Derivative of ln is 1 over y times dy dx equal to.
dy dxy.
Here, we're going to do product rule. So, u is x, v ln of x. U prime is 1, v prime 1 over x. So,
The derivative of logarithm of ln
is 1 over x. Yep.
Mm-hmm.
So here I have x times 1 over x plus 1 times ln of x. So I have 1 over y dy dx is equal to 1 plus ln of x. Next, I need to solve for y. I need to solve for dy dx. So I'm going to multiply y on both sides.
You got to distribute.
Yeah. Well, no. So here I have dy dx is equal to 1 plus ln of x times y.
Got it?
No, last step. I can't end with a y in there. So I go back to the original function. What was y in the original function? X to the x. So dy dx is equal to 1 plus ln of x, x to the x. That's it. And this is why, Ezra, we were told that x is greater than 0, because you have ln of x and x can't be negative, so you're told that that's for the domain. Okay?
And why do you change that to the x? Oh, because the y already
Right.
has x.
Okay, next one. Next one. Y equals x to the power of sine x. X to the power of sine x. So first take an ln of both sides. So ln of y is equal to ln of x to the sine x. Okay? Nothing, no math there even. Now comes the algebra. Sine x drops down. Ln of y equals sine x ln of x. Now take a derivative of both sides, right? So d dx, d dx. Okay, on the left-hand side, 1 over y dy dx equal to. Okay, right-hand side is a product rule, yes? Okay, this time we're gonna see if we can do the product rule sort of like on our feet, okay? Without writing u and v. Let's see if we can do that. So what is it? It's u v prime. So u sine x, v prime 1 over x. Okay, look, you see how I put the dot there? You see how clear it is that I'm multiplying? Okay, then what's the next one? Plus u prime cosine x times ln x. Okay, u prime v. Okay,
Wait a minute, what's the prime for ln x? It's 1 over x.
that was this one.
Right.
So uv prime plus u prime v. Now, do you see how clearly that plus sign separates the two terms?
Yes.
This was a thing on the quiz, right? That plus sign is disappearing and it's all becoming one term. Then that's not product rule. Okay. So now there is nothing I can simplify here. What I can do though is I can multiply both sides by y. So now I have dy dx.
But isn't it sine of x? dy?
Huh?
So did you plug in the original y values?
Yeah, hang on. I'm not done yet. Dy dx is, look, here, sine of x times 1 over x, I'm going to condense it and write sine of x over x plus ln of x cosine x, the order there doesn't matter, times y. And what is the y?
X sine x.
X to the sine x. So you know what? I'm going to write that in the front here. X to the sine x.
I thought exponential was after.
Yeah, but then there is also like a huge term, like a huge parenthesis. Okay, hang on. Let me.
Oh, I see what you're doing. You just moved it over.
Sine x over x plus ln of x cosine x. So yes, I was saying that. That was when there was like one term, right? But if there is a single term and then a parenthesis, the single term always goes before. You know, there is like, it's like the royalty in England. There's like precedence, right? It's like you can be a duchess and then a princess and then a something, and then you're like higher, and if you're like in a green room, you're higher than this person, and then if you're in a blue room, they're higher, so they curtsy to you. I don't know.
Blue.
I mean, I'm making things up.
When the queen is guest, she has like tiered rooms.
Well, no, that was just, I was just making fun. But like, there are like certain like situations when it's like a formal thing. I don't know, whatever. Okay. All right.
Word problem?
Word problems. Okay. The spread of a flu season in a certain school is modeled by this equation, P of T. Okay? Where P of T is the total number of students infected. Total number of students infected. T is days after the flu was first noticed. Okay? It's important for you to have a good accounting of what each and every single variable stands for, right? With its units and the time where it starts and everything.
Yeah, that showed up a lot.
Huh?
That showed up a lot in pre-calculus.
Yeah. And it's all calculus. This is all what it's about. Many of them may already be well again at time t, right? Okay. By the way, let's go ahead and have our graphing calculators out for this problem.
Got it.
Estimate the initial number of students infected with the flu. Okay. So, so the number of students infected with the flu is P of T. Initially, so what we want here at t equals 0. Okay? So what we want is P of 0. That's what we want.
There's no derivative there.
No derivative. This is just algebra 1 even. So it's 100 over 1 plus e to the 3 minus 0. And that's like 100 over 1 plus e cubed. And if you plug it in the calculator, which you don't have to right now, I'll tell you it's about 5 students.
4.75.
Yeah, so we round normally. You just round up or down. Round up and down according to the rules of math.
You can't have 3/4 of students.
Right.
Round up.
Round up.
No, round
Regular. Don't think
regular.
about
Yeah.
students, something
Okay.
else.
Now, here we go. How fast is the flu spreading after 3 days? What's another word for how fast?
Rate.
The rate of change, which would be velocity if this was position. Yes. Yep. The rate of change after 3 days, so it's the rate of change at t equals 3.
So it's P prime of 3.
P prime at 3 is what we want. So now, here is what we're going to do. Okay? We're not going to take a derivative of that by hand. I understand you might be able to, but we're not, because we need to learn to do this on the calculator as well. So, here we go. Tab. Okay, we're going to graph just that. So here, 100 over, in parentheses, please, 1 plus 3 to the power of, e to the power of, e to the power of 3 minus x. Okay, here we go. You graph it and it looks like this. This is, clearly you're not seeing the whole picture here. But there's also some things at play here, right? What does the horizontal axis represent in this problem? It's t, right? It's the number of days. So we know that the number of days can't be negative. It has to start from 0 and up. What does the vertical axis represent?
People.
It's the number of students, right? So let's go to menu, analyze graph. No, I'm sorry.
There's a DY option.
No, hang on. Let's go to window zoom. We can't even see the graph yet. Let's go to window zoom, window settings. It's of utmost importance for you to be able to fix the windows to accommodate the specific problem you're solving. Yeah? So, X-min is 0. Then press tab. Please get in the habit of cycling through these, toggling through these using the tab button, because it highlights it. It's so much easier. So we're going to go 0 to, I don't know, let's just go to 10. 10 days is a good round for the flu. And look, sometimes it's trial and error, okay? I've done this before, so I know it's going to be 10. I kind of have a spoiler, right? tab, tab. This is the number of students now. Number of students, okay, the minimum should be 0. Tab, how many people are going to get infected? You know what? I'm going to go to like 120. I don't know. Is that enough? I don't know. Let's see. Oh, look. Yeah, that is kind of cool. Now I see like a whole picture. Okay? When you see it leveling off like that, to that extent, you know, it looks like it's like you're done. Like the story's over there. Okay. Now I want the derivative. So go back to menu, analyze graph. Number 5 is dy dx. When you hit number 5, it asks you for position. Don't do anything. Type 3. Press the 3 button. Enter. Boom. The slope there is 25. Does it make sense that the slope over there is 25? Like over here, does it make sense that there is a rise of 25 and over 1? Yeah, because like this is 120. So like each increment can be about, you know, 10, 15, 20. So here, P prime of 3 is 25. Okay, fine. But you know what? Calculus is not just about getting the answer. What does this mean? 25 students what? Yeah, per day. After 3 days, 25 students per day are being infected. And we now know, like, we've been in this lingo, right, since we're in the pandemic. Right? So initially, you know, the first person may have, you know, maybe like 2 people a day were getting infected, or 10 people, and then at day 3, 25 people a day.
It's exponential increase. That's kind of until it flattens out.
Right.
So is it an average of the 3 days, or actually?
No. On the third day, 25 students a day are getting the flu, like still fresh getting the flu. You know how like with COVID, they were like there are like 100 cases a day. This is not the average. It's because it's just the school, you know. Okay. Next. When will the flu spread at its maximum rate? Okay, hang on. Stop for a minute. Listen. Maximum rate. Rate is the derivative. So this is saying the maximum of the derivative. So let's go to our calculators here. Go back, press tab, and go back to F2. We're going to graph here the derivative of this function. So press this button to the right of the 9, and you should have a button that says ddx or something, dd something.
dd blank, yeah.
Yep. Press that one.
dd blank of blank.
Yep. So it's going to be ddx. Please don't type the function. ddx of. Nope. We want the derivative of what we graphed in F1, right? So type in F1. It should bold it for you. Parentheses x. Enter. That is the derivative. Do you see how F1 is bolded? That means it's recognized, right? That's like the computer language. It recognized that string as a function. It's so cool. So now this is the derivative. Now we want the maximum of the derivative. Yeah?
So what you need to do is to go into menu. You click analyze graph. And then you click number 3 maximum.
Number 3 maximum.
Right, and then.
Okay, now it asks you which graph do you want me to find the maximum of. Just scroll on top of the red graph and press enter or the center button, and it picks it for you. Lower bound,
325.
upper bound.
325 exactly.
That's
My calculator like froze for a second while you were doing it. How would you send the
you just see
Okay, I'll tell you right now. Let me do this and then I'll tell you. So it's 3,25. That point, right? That point is t, instead of x and y, and P of T. So the 3, right, is the day, right? The day that it's happening. It's at T equals 3.
And then 3 days,
And then 3 days in, the maximum rate is 25. Okay? So it will spread. It spreads at the maximum rate at T equals 3. Okay, I'm answering the first question now. When will the flu spread at its maximum rate? At T equals 3, which means 3 days after the first case, yeah. Okay, now, the next question says, what is this rate? The maximum rate is not 25. It's 25 students per day. Okay?